Okay, in this video, we will continue with the problem. In the previous video, we had done maximum positive and negative shear force at C. Now, the second part of the question is to find the absolute maximum bending moment anywhere on the beam. Okay, anywhere on the beam. So, we have already discussed how to find what is the condition for getting this absolute maximum bending moment. For this, you have to find where is the center of gravity or the resultant, where is the position of resultant of the set of 5 concentrated loads which is given, and you have to find out to which wheel load that resultant is close to, and take that wheel load as a critical load which is kept over the section C, or um, which is positioned in such a way from the end A, so that you will get a position of loads for absolute maximum bending moment. So in order to find that, let us find where is the resultant. So let the center of gravity or the resultant of loads uh, corresponding to or from the leading wheel load. Leading wheel load means the first wheel load. So in this case, it is 120 kilonewton. B at a distance x. Okay. So this is all with respect to the leading wheel load. So that x is equal to, just look at the set of loads, its figure, I'll just mark it here. First you had a 120 kilonewton load, then you had a 180 kilonewton load, then 200, then you had 80, and finally the last 80. So this was spaced at 3 meters, then 2 meters, another 3 meters, and 2 meters. So with respect to this 120, we are going to take the, you're going to find the position of resultant. So 180 into 3 plus 200 into 5 plus 80 into 8 plus 80 into 10. Okay, divided by all the loads. So 120 plus 180 plus 200 plus 80 plus 80. So this gives you a value of 4.515 meters from that 120 kilonewton load. Okay. So that means resultant is placed at or is located as 4.515 meter from the leading load 120 kilonewton. Okay. Now we can also infer that, I'll just show it with a red ink. So 4.515 means this is already 4.5 here. Okay, so 4.51 means it will be somewhere here. This is the position of resultant. So from this end it is at 4.515 meters. Okay, so we can say that this resultant is close to this 200 kilonewton load. So let us write resultant is close to the 200 kilonewton load. Okay, hence we can infer that the absolute maximum moment is likely to develop under this load. Okay, maximum moment is likely to develop under this load. So this is what we do. So now we have to find what is the distance between these two loads. So distance of this critical load which we have selected, 200 kilonewton load, from the resultant R is given by 5 minus 4.515, because distance of the 200 kilonewton load from 120 kilonewton load is 5 meters. So 5 minus 4.515 gives you 0.4848 meters. Okay. Now what we have actually found is small d. Okay, when you check the derivation, this is distance of 200 kilonewton load from resultant d is nothing but 0.4848. Therefore, it is better to find the position of resultant. Let us find position of resultant first. Then we will find out position of 200 kilonewton load from the end A. So position of resultant R from end A, you have an equation for that, which is nothing but L by 2 minus D by 2. So that is given by L by 2 is nothing but 12 meters minus 0.4848 divided by 2, which gives you 11.7576 meters. But we cannot actually show the resultant exactly on the picture. We just have a train of concentrated load. So it is easier for us to find the position of 200 kilonewton load from end A. So for that, let us find what is that position. So position of 200 kilonewton load from end A is given by L by 2 plus D by 2. So that is equal to 12, 24 by 2. 12 plus 0.4848 divided by 2, which is equal to 12.242 meters. So this is how you have to position the load now for getting an absolute maximum bending moment. So I'll draw the span again. This is your simply supported beam AB. And how you will position the load? You will position that 200, like 12, this is a center span. So 12.2 means somewhere more than the center span. So this is 12.242, which means this distance will be 11.757. 11.757. Okay. And this point, okay, this is where you have to place your 200 kilonewton load. So the position of 200 kilonewton load from end A is shown. Now you place the other loads accordingly, according to the distances given in the question. So to the left of 200, you have 80 kilonewton load at 3 meter distance and another 80 2-meter distance. To the right of 200, you have at after 2 meters, you have a 180 kilonewton load, and after 3 meters, you have a 120 kilonewton load. Now, the corresponding ILD for bending moment is to be shown. So, I'm going to draw the ILD for bending moment, which is nothing but a triangle maximum under the 200 kilonewton load. Okay. Let us show the ordinates under each point load. So here you have one ordinate, then this is the next ordinate. This is a critical ordinate. Then here you have another one, and under 120 also you have an ordinate. So let us mark from here y1. This is y1, y2. Then you have yc here. Okay, this is yc. Then this be y3 and let this be y4. So this is 2 meters, this is 3 meters, this is 2 meters, 3 meters. So this much distance, when you subtract, you get 6.757 here, and this distance is 7.242. So now you have everything you need to find absolute maximum bending moment. So from this figure, therefore, the absolute maximum bending moment is given by 80 into y1 plus 80 into y2 plus 200 into yc plus 180 into y3 plus 120 into y4. Okay. What is yc? Yc is nothing but z into L minus z by L. Okay, critical ordinate. So here z is 12.242 into L minus z is 11.757 divided by 24, which is equal to 5.997. Okay, so you have found the critical ordinate. Now substitute in the equation, use the principle of similar triangles. I'm directly substituting in the equation. So absolute maximum bending moment is equal to 80 into y1. So 80 into y1 means 7.242 divided by 12.242 into yc. Okay, so we will take, multiply by yc. Yc is common in every term. So we will keep it outside. So this plus 80 into y2. Y2 is nothing but 9.242 divided by 12.242 plus 200 into yc, which is 5.997. Okay, so I'm going to write that in the end. So I'm not going to write it here. We'll put a bracket and write plus 200 plus 180 into y3. Y3 is 6789. So 9.757. 9.757 divided by 11.757 plus last one 120 into 6.757 divided by 11.757. This whole term is to be multiplied by 5.997, okay, which is your YC. Simplifying this, you will get a value of 3154.82 kilonewton meter. This is the answer. So I hope it is clear. Please check the calculations. Main thing is you have to remember the equations for positioning the load in such a way that you get a case of absolute maximum anywhere in the beam. Okay.